Now that you've seen some examples with multiplying and simplifying, let's try some more. So in this practice set, we need to multiply and simplify. And we're going to assume that no radicals were formed by raising negative numbers to even powers. So we're only looking at the principal simplified expressions. The square root of 2x to the fifth times the square root of 10x to the third. We have indexes that match, so we can just write it as the square root of 20 x to the eighth. Now if I think about 10 and 2, I know that I can break that apart. I can break this into 4 times 5. That's equivalent to 20, but 4 times 5 breaks it apart, so I have a perfect square here. Also, x to the eighth, well, that just can stay x to the eighth. The 4 is 2 to the second, so we can take that out as a 2. The x to the eighth, if we divide that by 2, we get 4. So x to the fourth can come out, and root 5 is the remainder inside the radical. Let's try part B. We have the cube root of 5a to the second times the cube root of 25, a to the fourth, b to the third, c to the seventh. This will give me the cube root of 125, a to the sixth, b to the third, c to the seventh. I know that 125 is a perfect cube, and so I'll take that out as a 5. A to the sixth, if you take the 6 and divide it by 2, you know that a squared will come out of the cube root. Same with b. b is to the third, divided by 3 gives me 1, so b to the 1 comes out. Lastly, this c to the seventh we know could also be thought of as c to the sixth times c, and so c to the second comes out, and we're left with the cube root of just c. Now let's look at the next example, part C. We have the fourth root of 20a to the third, b to the seventh, times the fourth root of 4a squared times b to the fifth. We're going to rewrite this under one root, the fourth root of, now we're going to take the 20 times the 4, that will give me 80, a to the fifth, b to the 12th. Remember, 80 could be broken down in 8 and 10, 2 and 4, 2 and 2. 10 can be broken down into 2 and 5. So my factors for the 80 is 2, 2, 2, 2, and 5. So I could write this as 2 to the fourth times 5. A to the fifth could be written as a times a to the fourth. And b to the 12th is already divisible by 4, so we can just leave it as b to the 12th. Now we can take out a 2. 4 divided by 4 is 1, so 2 to the 1. 5 is not coming out of the radical. A is not coming out of the radical, but a to the fourth can come out one time, because 4 divided by 4 as the index gives me 1. b to the 12th divided by 4 will give me b to the 12 over 4, or just b to the third. And so my remainder inside the radicals, so to speak, we'll make sure we put that 4 as an index on there. The remainder inside the radical is 5a. Let's take a look at this last one. We have the fifth root of x to the third times the quantity y plus z raised to the sixth times the fifth root of x to the third times y plus z raised to the fourth. The indexes match, and we can rewrite this as one very long fifth root. we'll have x to the 3 plus 3. So it'll have an exponent of 6. And y plus z raised to the 6 plus 4, which will be 10. Now, if we break this up into two parts, we'll have the fifth root of x times x to the fifth. We'll also have y plus z raised to the 10th, which is already divisible by 5 in the exponent. So I can take 1x out and y plus z raised to the second out. And I'll be left with the fifth root of x.